Next, George Legendre. He's principal of IJP, a UK-based architectural firm which explores the natural intersections between space, mathematics, and computation. This is what I like doing in my spare time. George holds a master's degree from the Harvard Graduate School of Design and actually serves there as an associate professor in practice. His work has been profiled in Wired, The New Scientist, The New York Times, The Financial Times, the Frankfurter Allgemeine, the Wall Street Journal, GQ Russia, NPR, Oprah.com, and CBS on Sunday. That's quite a list. Please join me in welcoming both Robert Hairston and George Legendre.
Thank you very much for having me. Art, that was a fantastic thing. It's been an amazing couple of days. Absolutely delighted. So good afternoon, everyone. And thank you for inviting me. So I'm a professor in practice of architecture at the Graduate School of Design, Harvard University. Now, after our wealthier cousins in business and law, we are Harvard's third professional faculty. A small disclaimer about words. You see, the term design, quote unquote, usually brings to mind chairs and tables. Our school is about the built environment at large. So we have 900 grads in architecture, urbanism, landscape architecture, planning law, urban policy, real estate, all under one roof, which sometimes leaks. I'm joking, it's not true. So I work in the United States, but I don't live here. I'm a commuter. I live in rural England and practice in London with IJP Architects, a design office with projects worldwide. You have attended already some really nice technical talks at this amazing conference. I just want to bring you the designer's cultural perspective and explain why industrialized wood and off-site manufacturing, which I refer to as OSM, are so important to us designers, culturally speaking. Sometimes it seems that OSM is like a new material, like graphene or polymer, you know, a new material with wondrous possibilities. Well, not quite. I mean, because OSM is not that new, is it? This German gentleman, the Bauhaus, first proposed it 100 years ago as a socially progressive model for mass housing. And indeed, affordable housing has been its vocation pretty much throughout the 20th century. Today, however, while need remains an important factor behind OSM, it's no longer the only one. You see, desire in all its contemporary forms is equally important. I'm thinking consumer politics, digital technology, social media culture, and of course, money. In Portugal, for instance, timber joiner Mima markets OSM as a luxury product rather than building. This is industrialized timber, and architecture for that matter, marketed as desirable accessories rather than the stuff of home or shelter. These ads suggest a return to the basics of dwelling and sitting around, but in truth, the product is quite expensive. The new minimalism isn't about ending consumerism. It's about taste, luxury, and inevitably about exclusion, a far cry from the real places where such dwellings remain the norm. Digital technology is chipping in as well. Cover, a small LA-based company with a secret house design algorithm, sees OSM as architecture's answer to Tesla. House design algorithms are an old, perhaps futile claim made by at least two generations of digital designers. But coming from Silicon Valley in the age of Uber, we could be ignoring this one at our own peril. And by the way, Cover collects credit card details from its clients before even meeting them. And I think we could all learn from that. OSM is often perceived to be about objects rather than places, and that's sometimes true. How else could you explain that in this Amsterdam factory, A group of makers creates houses by spinning recycled wood pulp around an axle. Yes, that's right. These people make homes like airport staff wrap suitcases with protective cling film. And it works beautifully. But maybe it's hard to take it seriously. And yet, OSM is not only about objects and one-offs. In post-industrial Manchester, the local urban and architectural language helped revive, one CLT box at a time, that enduring icon of European urbanity, the Edwardian terrace. In 21st century Britain, a culture completely obsessed with a house, these prefabs by architect Ched KM are among the most desirable homes. So in the UK, where Robert and I live and work, that is now the way of the world. A few years ago, a venture fund wishing to invest in housing would have reached out to you, developers, urbanists, engineers, architects, and local officials. Today, it's more likely to start the conversation by building itself a futuristic home factory. So yes, the social modernist project pioneered by the League of German Gentlemen is happening, all right, but in a pluralistic, unplanned, capitalistic way. So this new world is our background as designers, and it's very exciting. When sometime during the next 10 years the economies of scale kick in, OSM will be cheaper and greener than conventional construction. But there's more to it. There are a lot more reasons why industrialized construction is important to us designers. The real draw lies in recognizing that it's all about process, and a conceptual process at that. First of all, there's the primal pleasure of working that way, and it doesn't go away with age or education. These two grown men, and soon to hold a Harvard degree, hopefully, rediscover their inner child while exploring sophisticated integrations of transport and construction. With OSM, simple constraints inform our thinking, protocols of assembly, tooling, the width of a room, and of course, the width of a freeway on which it is trucked, one piece at a time, like a gigantic model from the land of Gulliver. Architect Andrew Wolff says that the width of the motorways will determine the form of future cities in the same way that a standard plot width determined the form of Victorian London. And he is right. And there's more. With its scale shifts, design patterns, and strangely direct translation from making to building, OSM has as much in common with the work that takes place here on the studios of the Harvard Graduate School of Design as it does with traditional building. Sometimes I even think that people out there in the industry aren't making buildings at all, that they're making one-to-one models. Or maybe it's the other way around. Robert and I were intrigued by the comparison, so we set out to systematically explore it for 2 years. My group approached the subject through making. We made models to understand the process of construction and delivery, models that serve as both design record and proof of concept, if you like, models as buildings. Robert introduced the case studies in his talk, Multiply by WTA, shown here in the courtyard of the V&A in London, Riverford Gardens and the Falkland Bothy up in Scotland, the futuristic Dyson Institute in Wiltshire. These projects couldn't be more different in scope and budget, but they were all planned and built in the same way. There are 3 key drivers behind our interpretation of OSM. The first is transport. OSM is about building anywhere that is, except on site. And that makes a lot of sense from the vantage point of quality control. Proponents of OSM will ask sensibly whether you'd buy a new car built in a field. So, OSM doesn't care where your site is, so long as the delivery man can reach it. It's a little bit like Little Chef, the British roadside diner, where the omelette on the menu isn't actually an option because, the waiter explains, head office hasn't put one in the post this morning. So yes, it's a fact. your doorstep could well be delivered to your doorstep one day. And we are interested in this scenario. So we looked at construction as a packaging problem, building as suitcase and building as crate. This, by the way, is already happening in practice. At CCG, closed panels are carefully gift-wrapped at the end of the assembly line. So we spent time exploring that problem, the problem of packaging, creating and decrating our future homes, and exploring visionary ideas at a smaller and experimental scale. Our second driver is the role of construction documents. As product design, manufacturing, and construction increasingly merge into one, tender packages in the future could look like self-help assembly manuals, like IKEA super brochures of sorts. We looked at this scenario in terms of graphic design, but also in terms of construction. Processing the original documents supplied by Robert was a key part of that approach, the raw material of the process. And the 3D models developed by the contractor and shop drawings coming from them are at the same unit-free scale, so we can use the same data to cut a timber at 1:1 in a building workshop or 3D print nylon at 1:30 on a kitchen table. There are a lot of analogies between these two processes, of which more later, but what matters here is that they share a single starting point. Off-site manufacturing means building by numbers as well as letters, so OSM won't work unless the parts are clearly labeled. Labeling is an integral part of the design process. We do it in our own practice, in London, where a kit of parts and a labeling protocol are both mathematically generated, with the same protocol finding its way seamlessly into construction. We saw something similar in action at CCG, where every single loose joist on the factory floor has a unique ID, usually printed, sometimes scribbled by hand, and held in a master list moving from monitor to monitor as the panel makes its way through the assembly line. Of all the factory floors I've been to, and there aren't that many, I have to say, CCG seemed to me by far the most futuristic. And don't get me wrong, there are no robots or drones around, just people. Drones are still a few years away. But I'm not talking about hardware, I'm talking about the firm's mindset. CCG's rigorous automation of the assembly process, complete with performance indicators and productivity bonuses for machine operators, offers a plausible vision for the future of construction. No OSM without proper labeling then, so we made sure that labels were properly integrated in our designs and dramatized for effect. Our goal was to fuse two things normally occurring in sequence and hence generally kept separate. The shop drawings on the one hand, the finished building on the other. That's it. Our third and final driver is the role of materials. So I'm sure you noticed there's quite a bit of plastic flying about. Plastic is not a material commonly associated with construction. We chose it for its transparency and the convenience of revealing the layers of joists, insulation, waterproof membrane, and finish of closed panels in residential construction. We were less concerned with the look and feel of materials, in this case wood. We were concerned with the breakdown and reassembly of the constituent parts, floor cassettes, closed panels, panels inside panels, and so on. That's probably where our working metaphor, building as model, model as building, breaks down a bit, because we have no use for real materiality. But that's not to say that the properties of wood were not important to us. Far from it. Our palette of choice did include wood, and two teams experimented rigorously with it. At scale 1:20, the bonded layers of plywood behave very much like the lamellas of CLT at full scale. But these structural properties are not rigorously scalable, so there's a limited value to the comparison. Of equal interest, perhaps, is the comparison between machines. Most of the material that goes into a closed panel is flat sheet cut, laid, and fastened using an arm with 3 degrees of freedom or axis and one fixed flat bed. From that narrow perspective anyway, this expensive machine on CCG's floor is no different from the laser cutter we use in my London office, or indeed from the fused filament deposition printers the students use to knock out working prototypes throughout the semester. Doing it this way is very convenient, but also kind of a conundrum. I wouldn't risk being tarred and feathered out of this room for suggesting we all swap wood for plastic. It's just uncanny that we choose to laminate something when cutting can do the job. Choosing the right manufacturing approach for the right constraint is not just a technical matter, but also an environmental one. So in the future, a rectangular frame with a square section could be printed using recycled wood pulp. In the meantime, it should probably just be cut. Finally, these models as buildings were designed to be performed. The students gave a demo this morning. We'll give another one after this. And most of the work is on display outside the hall. I'm going to leave you with a sampler of these performances, which can run up to 10 minutes each, and hope you enjoy them. I wish to thank the students for doing their outstanding research work and giving their consent for inclusion in this summary. So heartfelt thanks to Jing, Evangelos, Gia, Mark, Alkiviadis, Anstak, Julio, John, Mackenzie, Adrian, and Jessica Yuan. I had a great time working with you all. I also wish to thank Professor Robert Hairstans for this most fruitful of collaborations and for introducing us to the vibrant world of Scottish pre-manufactured wood. And finally, I wish to thank the Executive Committee of the Graduate School of Design for funding 2 research trips in Europe. Thank you very much.